Good afternoon, teacher. I'm gonna talk about the topics seen in this term. We start seeing realms of physics that is like fundamental magnitudes. That means that everything can be measured. We have three fundamental magnitudes: mass, time, and length. And we have composite magnitudes that can be, for example, acceleration, speed. The unit of mass is grams, the units of time are seconds, the unit of length is meters. And the composite, for example, if we talk about acceleration, it's meters divided seconds to the power of 2. So that are the realms of physics. Then we see like the bigger scene of physics. Like los extremos of physics. For example, in mass, the smallest thing measured was an electron, that is 10 to the power of minus 30, and the biggest was the observable universe, that is 10 to the power of 53. In length, the Planck distance, that was 10 to the power of minus 35, and the bigger one was 10 to the power of minus 26 with the observable universe. At the time was Planck's time with 10 to the power of minus 43, and age of the observable universe, that was 10 to the power of 17. Physics use a lot like order of magnitudes. Order of magnitudes is like another way to show a number. For example, 1000. I can show 1000 10 to the power of 3. Yes, like another way to say a number. Very shorter and no, it's better. For example, the age of a human being goes between 10 to the power of, in this case, 10 to the power of 1. That is 10 to 99. My age is 10 to the power of 1. My father's age is 10 to the power of 1. Because it's 10, is between 10 and 99. For example, the distance between from here to Santa Marta could be 10 to the power of 3. That is from 1999. In this case, kilometers. In this, we can relate this with scientific notation. Scientific notation is writing a number with another way. For example, the standard form of 10 to the power of 3 is 1000. The scientific notation of, for example, 10 is 10 to 1. The other the comparison of magnitudes. For example, I can compare the mass of the Earth with the mass of the Sun. So the Earth is 10 to the power of 24. The Sun is 10 to the power of 30. So I subtract the powers and I got the answer. The answer is 10 to the power of minus 6. So the Earth is 6 times smaller than the Sun. The other topic was the prefixes. The prefix is like a name to the power, to the magnitudes. Well, so we have 8 small and 6 big prefixes. Yes. So we have atto, femto, pico, nano, micro, milli. Atto, femto, pico, nano, micro, milli, centi. 7. Excuse me. And we have another 6 for big. There are kilo, mega, giga, tera, peta, and hexa. So atto goes with 10 to the power of minus 18, femto 10 to the power of minus 15, pico 10 to the power of 12, nano 10 to the power of minus 9, micro 10 to the power of 6, mainly 10 to the power of minus 3, and the rule change in this prefix, that is 10 to the power of minus 2. And then change again with kilo, because kilo is 10 to the power of 2. Kilo is used, for example, in kilograms commonly. So kilo mega, that goes to 10 to the power of 6. Kilo is 10 to the power of 3. The rule starts again. Mega is 10 to the power of 6, giga 10 to the power of 9, theta 10 to the power of 12, theta 10 to the power of 15, and exa 10 to the power of 18. So we have like a better way to say magnitude. For example, I already said the Earth is 10 to the power of 24. Okay, no, the example doesn't work. For example, with the age of the universe, that is 10 to the power of 18. So we can say that the Earth is 10 to the power of 2 petaseconds. It's a better way to say that. If we want to name like the magnitude, and not to say 10 to the power of 17. Okay, scientific notation. Scientific notation, I already say, is like a way to say a number. For example, 1000 can be 10 to the power of 3, 10 to the power of 1. So we have like and that goes the significant figure. The significant figures are like the values we can trust. In this case, we have 4 rules for that. We got we got 4 rules. The first rule is like when a number doesn't have zeros, we can trust in all the value. For example, 3193, we can trust also it has 4 significant figures. When they are starting zeros, for example 0.00041, we don't trust of any of these zeros, but we trust in the numbers, non-zero numbers. For example, 41. This number has only 2 significant figures. We talk about zeros in the middle. For example, 20.04. We have 4 significant figures because are between non-zero numbers. And the last rule is like trailing zeros. The trailing zeros are the ending. It depends if they are decimal or if they are integer. If they are integer, for example, 200, you don't trust. So we have 1 significant figure. If we have a decimal number, for example 200.0, we trust in all of the values because I can assure that I measure the 4 of the numbers, because we have a less uncertainty, a relative uncertainty. Uncertainty is like the percentage of error in a measurement. We have the relative uncertainty and the absolute uncertainty. The absolute uncertainty can be written like this. So this is my height. So 1.52. 3. So I have this absolute uncertainty, and I write my length más o menos 0.001, and that is my absolute. The percentage, and I have the percentage the teacher gave us an example with Marinita's pastel de pollo. Marinita report 0.01 kilograms of uncertainty. So here her relative uncertainty is of 3%. We take out the relative uncertainty by uncertainty divide measurement times 100, and it is a percentage. So we have a rule with this of uncertainty. for example, we operation with significant figures. So the rule is the number of significant figures of an answer of an operation has the same number of significant figures as the least number of significant figures used to calculate. For example, in our workshop we have that. So we have this. We have this, for example, this example. So 23.7 times 3.8. The significant figures here in this first number is 3. So 3. And in the second one is 2. So 2. The answer can have more. So the answer of this is 90.06. So the answer here, I have 2. So I only can have 2 significant values. So I cancel this, and this, my main answer here is 90. We have a rule of estimating. When the number including the significant values is bigger than 5, we estimate to the other number. For example, this example could be with this. So I have 43.678 times 64.1. My first number, this one, have 1, 2, 3, 4, and 5 significant figures. And my second number has 3 significant figures. So my number can only have 3. So the answer of this is 2799.7598. I estimate, and my answer here should be 2, 0, 0, and 0, because I am using the rule and I am estimating. Basically, we have to graph uncertainty. We put the title, the level axis, the scale, points, and the uncertainty. The uncertainty has to be with the x and the y. So if the uncertainty is very big, your period gonna be like this. So you have to assure that your uncertainty is short to make a point to be a point and not an x or a cross. And that basically is the topics we have seen this term. Thank you, teacher. Good afternoon.